Hello everyone. Until now we covered the topics about importing the geometry and generating the mesh. The next step is to do the setup using Ansys Fluent. If you right click on that and then click on edit, it will open the Fluent for us. Before that, we always have some options. We can click on double precision, which is basically for storing the numbers in double precision than single. And also we can solve the simulations in parallel. It means that instead of one CPU, we can use one for, it depends on the cluster or the PC that we have. When it opens the Fluent for us, on the left side, we see some steps that we have to fill them. It contains setup, solution, and result. And you see that if we want to explain them more accurately, basically we have to fill them step by step. So to set up a simulation using Fluent, we have to fill the steps in Fluent. It contains from general, model, material, boundary conditions, and sometimes we want to report some values during simulations. So here on the left side, you see that we have to fill all of them step by step. So we can always start from the left side, go to each of them one by one and fill if they are relevant for you. Then it's the easiest way to set up the simulations. So if you look at the left side, the first part is general. And then when it opened the panel for us on the general section, we see an information about the mesh, about the solver and time step. On the mesh side, we can check the scale of the mesh. We should always be careful about the length that we want to work with that or to see. Here on the left side, we see the view length unit. And also on the right side, we see the length that we created the mesh with that. If it is important to rescale it, and always check the box dimensions to be careful that everything is correct. Then the next step after importing any mesh is to check the mesh. Basically, it will gives us the information about the minimum face area, the minimum volume, maximum volume, and also the coordinate of the domain. Should always be careful to check the volume statistics because we shouldn't have any negative volumes. All the volumes should be positive. And then we can always check that by checking the mesh. We don't go for the solver. Today's topic is not about choosing the solver, but the next step, which is also important, is the time. We want to solve the simulation using an steady or unsteady solver, and the gravity is not relevant for us. So the next one after the general is the model. Every time we want to solve the flow, we can have different options. If it is multi-phase flow, if we want to solve the heat transfer, which is the energy, but for us, the viscous is the important one. We don't want to solve the flow using the turbulent model, so we go to choose the laminar one for today's tutorial, but you can always choose between all these models, depend on what you want to do and the accuracy that you expect to receive. Then the next one is to create the material for us. The material or basically the fluid that we have is the blood. So just right click on the fluid and click on the new. Then we can here specify our fluid, which is blood. Then we can write the blood there. We can choose the density from the literature. Sometimes it's 1060, 1056. So we go for the 1060, and also for the viscosity based on the literature, we can choose 10 to the minus 3 for that. So here I should correct this one. Then you can click on the change, and then you can rewrite that because we don't have any air. So we only want to have a blood. Then, as you see, the fluid instead of air is now blood. Now we have to choose our fluid to be blood. Sometimes when you have a multi-phase flow, then you have to choose between your zone that which one is blood, for example, which one is the another one. So here we have only blood, so automatically it will be chosen for the fluid. The next and the main important part in Fluent is to specify the boundary condition. As you can see, we have an inlet, we have internal, which is the internal mesh or the blood. We have two outlets, outlet 1 and 2, and also we have the wall of the geometry. Here we can see or display the mesh. Basically, if you click on that part, we can choose between all the surfaces that we have, inlet to outlet and also the wall. For example, if we choose the wall, we don't see anymore the boundaries because the inlet and the outlet boundaries because we didn't choose them. If we just choose the outlet, then it only shows the surface of the outlet for us. And you can also do it for the inlet and any part that you want to see. We can always choose it from the display mesh here. As we can see it, there are some other options also. If you just click on the thick one, we can choose all of them. Also on the left side on the options, if you click on the edges, then it also shows the mesh that we created in the previous setup. And then you can again double check your mesh if it is relevant for you to look at it. If not, you can always turn it off. So until now, everything was okay. Then we go to specify our boundary conditions. The inlet for us is just the velocity, and we want to choose a constant velocity for that. So we double click on inlet, and then we have a velocity specification method. Basically, we want to specify the velocity to be normal to the boundary and a constant value of 0.25. Then we click on apply and then we close it. The next one would be the outlet because for the internal it's just the interface and we cannot choose anything for that. It will be solved by the Navier-Stokes. But for the outlets, we want to choose pressure outlet to be a gauge pressure of 0, again normal to the boundary, and then we click on apply. For the outlet 2 also would be the same, and then for the wall, we don't have a lot of options, but it's always good to check that. Automatically Fluent choose the wall to be stationary and to be non-slip. The non-slip means that the velocity on the wall would be 0, and you can always check it after you get some results. Sometimes we need to follow and also to report some parameters during the simulations. For that, we can define them in the report definitions. If you right click and then click on the new, here we can define any parameters that we want to check. For example, we can go for the mass flow rates at the two inlets that we have. So here also we can specify the names. For example, mass flow rate for the outlet 1. And then we can choose the outlet from the surfaces because you always have to specify where you want to measure your mass flow rates. Because of that, we always have to choose that. And also we can print to console. That means that in addition to the saving the data, we also want to look at it while it is running. It's also a good thing that to check and to be sure that your simulation is correct. Then we can go for the mass flow rate for the second outlet. Again, in the same manner, we can specify the name for the outlet 2. We can just write it mass flow rate 2. And then again, you have to specify the surface, which is the outlet 2 for. Then we have two report definitions, mass flow rate at the outlet 1 and outlet 2. And then we can close it. So now if you go on the monitors, you can always see what you have for the report files and also the plots. Automatically, they will be here saved and also reported per iteration or per time step when we solve. The next one is the initialization. Basically, initialization in Fluent means that we need to specify an initial value for all the parameters. We have a two method. Hybrid initialization and standard. For the hybrid one, it just solves a simplified set of equation to create a non-uniform initial flow, but for the standard one, it assigns just a single constant value to all the variables. So we always recommended to choose the hybrid initialization. When we want to use the Fluent, we just right click on that and then click on initialization. It will initialize that and give initial value to all the parameters. Here you don't need to be worried about this warning basically because we didn't solve any equation until now, so we didn't reach to the convergence criteria and it just says that it didn't reach to that. And the last part is running the equation, running the calculation. We have because we have a steady, so here we have only the number of iteration. We choose it to be 1000. Before running the calculation, we can also double check some more things, the methods and the controls. In the method parts, basically we can see the different scheme that we discussed before, like the simple is the simple C, the piezo and the coupled one. The coupled means that it's coupled between the simple and the piezo. We can also specify the different numerical scheme for pressure, for momentum, and we always leave them on the default only if we want to have a very specific one. And here we can see the relaxation factors that we have. Sometimes depends on the application. We have also to tweak them and to refine them to have a better convergency, which is not the topic of today's tutorial, but we can discuss it later. So when everything is ready and we are satisfied, we can just click on the calculation and it will start running the simulation and calculating per iteration because we are running a steady simulation. Here on the screen, you see the mass flow rate for the outlet 2, which shows per iteration, and we choose to have a 1000 iteration. And also in the console, we see that per iteration, what is the residuals that we have for the continuity x, y, z velocity. Here we see the mass flow rate 1, mass flow rate 2, and the scaled residuals. The residuals basically shows that how our simulation is converging to the criteria that we chose. Here by default is 10 to the minus 3. When everything is finished and the calculation is complete, we can just close the Fluent and go for the next step, which is the post-processing of the result.